Thank you. Well, welcome everybody. Thank you for being here. I am today talking about Web3, and it's okay if you don't know what it is, because I'm here to explain that today. And I will show you, like, from zero, what it is Web3, what is blockchain technology, and how we can build actually a Web3 application from zero. So before I will introduce myself shortly, I am a lead software developer at Scaling Parrots. Scaling Parrots is a small company in the north of Italy. I'm Italian, by the way. And I love Frontend, and I'm actually a Frontend specialist. And I work with Web3 like in the couple years or so. And I really love Web3, like as a technology, and I like to talk about it because, like, sometimes when we talk about like Web3 and blockchain, it's always like about speculation stuff and not the technology itself. So what I do is telling about what is Web3 as a technology. And I love technology in general and everything that it's technology. And this is my stack. I love the first Angular new logo. And I love Angular. It's like my first go on. And I will show you also with Web3 how it's simple to do that. So Web3, when we talk about Web3, we talk about our decentralized web. So the definition of Web3 is decentralized web. And when we talk about decentralization, it's mainly blockchain technology. So in particular in this talk, when we talk about a decentralized application, so a Web3 application, it means a blockchain that application, so an application that uses blockchains. To explain Web3, I like to make a little bit of a comparison between like Web2, what we are used to, and Web3. So Web3 is decentralized. So Web2 is non-decentralized, so is a centralized web. What does it mean? It means that there is always a central control. What that means? When we like use the internet, there is always someone that decides for us if we can do something or not. For example, if I want to upload a video on the internet, I need to be like in someone else's house, let's say, because like if I want to upload a video, I need to go to YouTube, for example, and build and upload my video in YouTube. So it's someone else's like application, it's someone else's place where I can put my stuff in it. And YouTube can accept my video or can like decide that my video is not like compatible or it's not good for the internet, so it can just throw it out. And you cannot actually explain yourself. So why my video cannot be on the internet, you can know or you cannot know. The difference in Web3 is that it's decentralized. So there is no one that controls if you can do something or not. There is the technology that decides. And the technology is open source. So there is always like a smart contract that decides how the video can be like compliant to the web. And you can check these rules by yourself. So if your video does not respect those rules, it will be like thrown away. Otherwise, it will be on the internet. And this is like a good thing about Web3, that you can always like know, because it's always like clear and you can read everything that you can do and you cannot do. Another thing is like payments. In Web3, payments are built in with the technology itself. In Web2, when we now need to do a payment, for example, on an e-commerce, if we want to pay, we need to use like someone else's tool, like PayPal or Stripe or anything. So it's someone else's tool that we give our money to, and then give it to the right, let's say, person. But in Web3, we have the payments like built in the web itself. So as we identify in the Web3, we have a wallet, and in our wallet we can transfer not only money but assets. Like, we don't have money in Web3, we have assets that can be like token, crypto, as you can know, or always assets like, I don't know, NFTs, or any like digital asset. We can transfer it in any moment from our wallet to another wallet or to our smart contract if it's like controlled by a smart contracts. And another important thing in Web3 is identity. Because like in Web2, when we need like to log in or like use an application, we need to sign up with our name, our last name, email, and stuff. So we need to give all the informations. But in Web3, we have this wallet that is built in technology. And with our wallet, that is just a wallet address that is like an hash that identifies us into the web. So when we need like to log in into an application, we just use our wallet and we are like signed in. So there are so many good stuff about Web3, but I'm not a Web3 maximalist. I don't want to say like everything is good, everything is fun, but I want to see like pro and cons of Web3. So the first pro is decentralization. As we just see, the ownership, everything that we upload on the internet, it's our property. So we can decide if we want to keep it on the internet or remove it, and there is no trace of our stuff anymore. Security, it's secure because like it's open source, everything, so you can read what's going on. And so you are secure because you know what's going on under the hood. Interoperability, you can access Web3 in any device, so it's not just on your computer. Any device you can use Web3 and permissionless. You do not need the permission of anyone, like big company or so, to build your stuff on Web3. Cons. Scalability. Web3 is a new technology, not that new because it's like a few years now that we have like blockchain and stuff, but still it's a little bit difficult like to learn about it and to improve what you're doing, because like user adoption is still really little because there are so many people that don't even know what Web3 is. So we need like to spread the word and make people like try it on first, and then maybe we can have more users using that. It's complex. There is no documentation enough on the internet, so for beginners, it's a little bit tough at the beginning. Now we have some examples on the internet, but still we are missing some documentation. Environment impact. We all know how much like impacts our environment for like transactions, all the gas fees and stuff. So it's still something that we need to improve as a community. And the community is working on that, actually. It's really active, but still we have some problems. But I like to show this picture because it's like, it represents how in 50 years the technology has changed, and from like a big computer that is like massive to something that can stay in a hand. So I have like the hope that we can improve all these like cons of Web3 in a little small amount of time, because like with the technology of that time, we could do that in 50 years. So I'm hopeful that in less years we can solve the problems that we have with Web3. let's see some use cases. What I can build with Web3? What can we find now, like in the internet? What we can find as use cases? First of all, DeFi. It's like how it's built, because like we have all these people talking about crypto, because like DeFi is decentralized finance. So we have all these tokens that are like financial tokens that we can use these platforms to like grow our property of the tokens. So we have some tokens, we can like invest them and or like change them with other tokens or utility tokens that we can have like benefits on the platforms. All that kind of stuff, like once you have like a token of the platform, you can use it to get some benefits from the platforms itself. DeFi and gamify. Gamify is like DeFi with gaming. So it's like a gaming application, traditional gaming application with some benefits on it. So when you're playing, you earn like tokens, and are not like fake tokens that are just in the game. Like now with traditional games, when you play a lot, you gain like prizes or like coins or stuff that you can use in the game itself. But with gamify, all the things that you earn, like all the assets that you earn, you own it actually, because they are on your wallet. So when you are outside the game, you can use that stuff. Like you can sell it, like for NFTs, you can sell it on another marketplace, or tokens you can like send them to a friend or someone else. So it's something that you earn, and you have always also outside the game. NFT marketplaces. A couple of years ago, there was like a boom of NFTs. You can like, so I'm sure that you have seen all the monkeys that like worth millions of dollars. Now NFTs are not just art, because they are called also like collectibles, because it's something that you collect and you show off with it, you flex, but it's not something that you can use for something like other than sell it and make money with that. Now NFTs can be used for something really cool, like to prove the ownership of something. Like you buy a house, you can like make an NFT that is a proof that the house is yours. And this is like stored in the blockchain. The blockchain, it's like immutable. You cannot like change anything or delete anything. So it's a real proof of something. And the NFTs actually have been used a lot lately for like real estates, for pharmacy, for like proving the production of something. And this is a real use case instead of like art, even if art is cool, but it's not that useful. Lastly, I want to talk about social media. We don't have so much social media because of the user adoption. We have some social media, and the social media is like standard social media. You can like post like your posts or your photos, videos, and you have ownership of what you upload, and you are free to upload whatever you want, with the only thing that you need to stick to the rules of the social media itself. And we have a couple of examples, like Blue Sky. Someone say have like Blue Sky. It's not that used because like it's invitation only, so it's another step that don't give us a lot of adoption for users, but still is trying to be used more and more. It's not like Twitter, but it's coming. So let's talk about development now. So for Web3 development, let's say Web2 is what we build like now. We have the browser that talks with a server, and in the server you have like everything. The front end, the back end that speaks with the database. And so everything is on a server. With Web3 now, we have something different. We have the browser, so the user that is on the browser and speaks with the web server that has the front end. So the front end is not changing. It changed just that we are not speaking with a backend or a database anymore, because we don't need database because all the data that we need are stored in the blockchain. So to speak with the front end and to get the information from the blockchain, we are using smart contracts. Smart contracts are just programming, computer programming that automates some actions in the blockchain. So we can read and write data in the blockchain. So everything we need, just smart contracts that speak with the blockchain, and the front end is just changing the way that communicates with that, but everything is more simple. And to the front end to speak with smart contract, we need providers. Providers are just like HTTP like calls, and we can use some free or public providers to interact with the blockchain to read data. But if we want to write some data, we need to sign all the information that we are going to write. So we need MetaMask, that is our wallet. So it's how we identify in the blockchain. So we need our wallet to connect with the front end to sign all our transaction, all the stuff that we are writing on the blockchain. How we can do that? We need some Web3 developer tools. First of all, front end is not changing. We need something that is JavaScript friendly, but we can use any framework or any library that you want. So front end not changing. We need wallet. MetaMask is like the most popular wallet. It's a browser extension. It's also like an app for your phone, so you can use it for both mobile and desktop. And we need this library that is JavaScript. So where JavaScript is running, you can use that. It's like our best friend for Web3, because to do anything in Web3, we need this library. Smart contracts. Smart contracts are just computer programs that's it's written in Solidity. Solidity is a programming language. And once the code is compiled, you get these APIs that are just, it's an array of objects, and every object is like the translation of the function on the smart contract. So for every function on the smart contract, you get like this object that has the name of the function that I want to call, all the arguments that you need to pass to that function, that are all the inputs with the type and the name of it. And also you can know if it's a read or a write. So if it's a function that will return you as an output an information that you are reading from the blockchain, or if it's just like payable or not payable, it means that you are writing something on the blockchain. We'll see an example later. Then we have the explorers. Explorers, you have Explorer for every blockchain that you are using. In this case, is Etherscan, is the explorer for Ethereum blockchain. And here you can look for every smart contract that is deployed. Once you have the hash, the address code of the smart contract, you can look for it. And here you have the code. There is all the code of the smart contract that is open source. And then you have filtered functions, the read functions and the write functions. So here you have all the information that you can read from the smart contract, and you can try it on. So when you build something, you can always double check what you are doing on your application using that. It's like a Swagger or Postman for Web3. Ether.js, it's just ethers. You can install it to NPM, and it's just the import. It's really simple. It's import ethers from ethers, and you are done. From ethers, we need two classes that are important: the provider class and the contract class. So the provider is this class that allows you to read the information and to interact with the smart contracts. And the contract class is connecting the front end with a specific smart contract. What we can do in Web3, we just need three things to be able to do three things. The first one is how to interact with the wallet, so your wallet, how to read from a smart contract, and how to write in a smart contract. Three things. From the wallet, we are getting the wallet address, that is our identification in the web, the provider that allows us to sign our transactions, and the network, because we need to know, when we build an application, we need to know if the wallet that is connected with us is connected on the same network as that we are building our application with. For example, if our application is built with Ethereum, we need to know that the wallet that is connected is also connecting to Ethereum and not Polygon or BNB or stuff. Read and write. So this is an example of a read function. So it's the name, how to get the name of the smart contract. The output is the name, that is type string. And you can see state mutability is a view. So it's something that you read. Here we have the write, that is transfer. So we are transferring an amount from our wallet to another wallet. The input that we need to pass is the address that we need to transfer that amount to, and the value. And as an output, we have this Boolean. So it's true or false if it succeeded or not. And state mutability is non-payable. It can be non-payable or payable for all the write functions. Provider. The provider is really important, and we have two kinds of provider, and allows us to speak from the front end to the smart contracts. Two types of providers. We have the wallet providers, it's our MetaMask provider, or there are some public nodes that can be free. There is always a free public node, or you can buy some let's say quick nodes that can be used into your front end. Let's see an example. So we need the wallet provider. To get our wallet provider, we need to ask MetaMask to get it. So where is the MetaMask provider located. It's in the window.ethereum object. It's in the window because it's a browser extension, so you will find all the information in the window. And once you have this object, you need to translate it on for ethers that can be like used with ethers. And we use this method that is Web3 provider, and we're passing the provider that we just get from the browser. Once we have it, we can like get all the other information, like the wallet address. That is just like send Ethereum request, and it's like an array because we are getting all the wallets that are connected, but it's always like just one address. You are getting the actual address that is connected in that time, and the network to like check if the wallet is connected to the same network. It's just get network, and you get it. If we are using a public node provider, we just need the RPC URL. This case is the BNB, the Binance public provider. It's a free provider that you can find on their website. And to get the provider for ethers, we just need this provider.json RPC provider, and we pass in the provider that we just copied. And then we can build our contract manager. The contract manager is the, let's say, built-in contract that we are calling, and we are just passing using this contract class from ethers, and we are passing the smart contract address, the ABIs of that smart contract that we can like check on the Explorer, and we can like download it from there, and the provider that we want to use. And then once we have the contract manager, we can pass the method name, so the name of the function that we want to check from the smart contracts, and pass all the inputs, so all the arguments that we want. And this works for the read and the writes. So once you learn how to do it, you can do any smart contract call. The only difference is the provider, because like if we are doing a read, so we are just reading an information, we can use both the wallet provider and the public nodes provider. So it's important to use the public nodes provider just to reading stuff on the blockchain. But if we want to write something, it's important to use the wallet provider. We can just use the wallet because we need to sign the transaction. And this is important, in particular, like to be able to read information without having the provider of the wallet. Because sometimes, like, for example, if we have like an NFT marketplace, and I am, as a user, wants like to go explore the website before like connecting my wallet, because if I'm not like interested on like buying or interact with any NFT on this like platform, I don't need to connect my wallet. But if we have not like a wallet connected, we need somewhere where to read all the information, like the information of the NFTs. And public nodes help us with that, because we can use like another provider to just read the data, show the NFTs to the user, and then make them connect their wallet and interact. So let's try it out. Let's build a Web3 application for DeFi that displays our current boost balance and allows us to transfer some boost to another wallet. So I'm using Boost because it's one of the most used stable coins and is like on Binance. And here we have some code to do these two operations. First of all, we need the user address. Here I just like repeated the function that we did earlier, but I did it like in another way to give you like multiple ways to get the same information. In this case, I'm just using the signer. So from the provider, I'm getting the signer, and then to get the user address from the signer, I can just use this method gets address. It's like simpler. And then here I have ABIs. This is the smart contract address, and this is another way to write ABIs. So we can write it as an array of objects, but also like an array of strings. And every string, as you can see, is like a function of the smart contracts. In this case, we have like the balance of, that is a view, so it's a read, sorry. And we need to pass the owner address, and we have in return the balance, that is a uint. And for the transfer is, we need to pass these two informations, and we are getting a Boolean for success. And then we are building our Boost contract, that is the contract manager. With the contract class, we are passing the Boost address, the ABIs, and the signer. So the signer is the provider in this case. Once you have this contract manager, we are going to read the Boost balance. The Boost balance is just the contract manager Boost contract dot balance of. That is the name of the function. And we are passing our user address. So the address that we are getting from the wallet that is connected. Once we have that, we are getting this result that is a big number, because blockchain always gives us big numbers as a result. And to like translate it to something that we can read, we can use these utils from ethers. It's always ethers that we are using. We are passing this, and this 18 is the name of the number of decimals that these smart contracts. You can read that information in the smart contracts also. Then we are going to transfer the amount. We are getting the same contract manager as we did earlier, and we are doing this transaction. That is the contract manager dot transfer. That is the name of the function. We are passing the receiver wallet address and the amount that we want to transfer. And if we do this transaction.wait, we can get the result of the transaction. Because once you do this call, it will open up this pop-up of MetaMask. In this case, I was transferring one Boost to this wallet address. Here you have all the recap, the amount that you are going to pay. There is always the fees that you need to pay to do a transfer. And you can confirm or reject. To get this information, because like we need to know if the user actually confirmed or reject the transaction, we need to wait for this transfer. And once it's confirmed, we are getting also, like, we can read multiple information, and one of them is the block number. So we can also like know in which block of the blockchain is stored this information of the transfer that we have done. And that's it. This demo, you can find it also in my GitHub. It's this repository Web3 Angular demo. I did it in Angular because, first of all, I love Angular, but because you can find a lot of like React examples on the internet, and you cannot find many people working with Angular, so I wanted to do like something different that you can not find that easily in the internet. And the branch name is Boost. It's for the example that we have just seen. And that's it. You can find me pretty much everywhere. This is like my GitHub if you want to try the demo. And yeah, thank you very much.
Thank you very much, Soumaya. Do we have questions? Yes, we have two. First, I will go there, and I will go back here.
Thank you. What kind of future do you see for the Web3 applications? Do they have potential to replace existing web infrastructure or more like an addition to it?
Okay, so I have faith because it's something that I'm working on and I'm passionate about, even if I'm not a maximalist, because I'm not saying that it's really cool and it's amazing to like build with blockchain, but like nowadays we have so much speculation that it's like hiding all the fun stuff about building in Web3. We need to spread the word more about the technology, and then we can actually like have some better uses for the blockchain. As I said earlier, like NFTs started with art, and now we have like a better use of NFTs. So we need some use cases that are really like useful and like more strong for the community, I guess.
Hi.
Hello.
I have a question about, because every time I hear Web3, this is crypto-oriented, and this is what is basically you can find everywhere on internet, right?
Yeah.
But in the beginning, when you spoke about use cases, you mentioned, yeah, you can put your video, and then when you don't want it to be there in decentralized mode, you just get it out, and this is done. And I started to think, is this how it will work by following your demo? Let's say how it will be different, because in this example, that is obvious. Yes, crypto, this is blockchain, 100%. When it's a regular video and Web3 and the blockchain, this is something that just doesn't get in my head at the moment. Maybe you can clarify how it will work in the use case of uploading video in Web3 mode.
Okay, so first of all, when you upload something, so if you are working with blockchain, you cannot store a file into the blockchain. So this is the first thing. So we are still using some providers to hash a video or a photo for like NFTs, for example. If we hash the information, is still we don't have the video itself into the blockchain. So I'm not. So for now, we are not decentralized 100% for videos and photos because it's files and not something that you can just hash and put in the blockchain. So it's something that you can delete because it's something that is not like stored in the blockchain. So once you don't want this information to be there, you can just delete it from, I don't know, for photos and video, I use EPFS, for example. And once you don't want your video to be anymore, you can just delete it from EPFS. It's like, I call it a database for files in the blockchain. Because, yeah, sometimes you find like the name decentralized, but it's not decentralized 100% yet for files. So for me, once you delete it, it's gone. You just have an hash for something that it's not existing anymore. But I think that we need to work more on that too, because like it's something that it started not that long ago, so we don't have so much like use cases that we can like be like firmly convinced of what we can actually do with it.
Do you want to react? Okay, perfect. We have another question, right?
I could probably add to this. So still there is some blockchain, it has hardware behind it, and someone has to pay it for it. So in social media, for example, if you switch to Web3, who is now paying for the hardware that stores those hashes, and how that limits users or changes the operational costs?
So it depends on who is building the social media. Some social media that I've built for clients, for example, sometimes they, once you like sign in on the social media, they give you like some free tokens to like use it for transactions, like to start, to make you, let's say, use the application. But when you are uploading something, you are like making a transaction, so you need to pay for every transaction. So the company that is behind the social media, or like the community that is building a social media, for example, can like pay for the infrastructure, so to do everything it's behind the social media, like all the smart contracts that have been deployed, or all the stuff that needs to be there, but also the user needs to pay for every transaction that he is doing.
Do you want to react? Perfect. Do we have other questions? Okay, we have one hand.
Thanks for the session. It was interesting. I want to ask about database. How to store data in these Web3 applications?
Data, you just store it on the blockchain itself. So every time that you write an information, you are actually write it in the blockchain. And everything that you read back, you read it from the blockchain. So you don't need a database anymore, actually. Not that much, but you can do like multiple transactions. There is no limits for like, it's like a chain of blocks that just continues to be added, and there is no limits for that. There is so much like space for it. It's not like something limited that you cannot. The only limit is like for files, because you cannot like store a file, and still we need, for now we have like just providers that gives us, we just store like the information of where you can find that files, and that's it.